to convert this quadratic function from standard form into vertex form. Here's the function. It's f of x is negative 3x squared plus 12x minus 17. This process of going from standard form to vertex form is usually called completing the square. Right now we're in standard form. We want to get into vertex form, which looks like a constant term times x minus some constant h all squared plus k. And the stipulation here is that a is non-zero, because if a were 0, we wouldn't have a quadratic. So the first step, I write it out kind of explicitly just so I don't forget. In order for this to do this process, we need to have an a value of 1. Currently, we have an a value of negative 3. So basically, I'm just going to divide the whole function through by negative 3. But instead of just doing that, I'm going to write it out explicitly and call it a new function, so that at the very end of the problem, when I've got something in vertex form, I don't forget to multiply through by negative 3 at the end. So first step is pretty much just dividing out your a term so that you have an a term of 1. But don't forget that, we're changing the function. We got to change it back. Step number 2 is to set your g of x equal to 0, which we just did. Then you want to isolate, for step number 3, you want to isolate all of your variables on one side and your constant terms on the other. So to do that, I just subtracted 17/3 from both sides. Then step number 4 is kind of the chunky part. We're basically trying to get the variables on the left-hand side of the equation. We're trying to force them into something that looks like our vertex form, right? We want a term that's squared. So in order to do that, we're going to take whatever the coefficient of the x term is, the b value, in this case it's negative 4, divide that by 2, square the entire thing, and then add that number to both sides of the equation. So here we've got b is negative 4. To figure out what number we're going to add to both sides, you take negative 4, or your b value, divide by 2 and square it, and add it to both sides. So this is what we've got. Basically what this is doing, we're selecting a very particular number to add to both sides so that we can force, in the next step, we can factor it out, that left-hand side of the equation, to look like a squared term, or a perfect square. So if you remember from factoring, we're looking for a pair of numbers that will add to this constant term, then multiply to that constant term and add to this term in the middle, and that's negative 2 and negative 2. We're going to multiply to negative 4 and then add to negative 4, which is a perfect x minus 2 times x minus 2. So we've got a perfect square, which is exactly what we wanted. You know that you did this step number 4 wrong if you can't, in the next step, create a perfect square. So we factor it out. We got a perfect square because that's exactly why we added 4 to both sides, was to force a perfect square. And then I just simplified down the right-hand side of the equation. Negative 17/3 plus 4. So now that we've got all that, we basically just move that constant term to the right-hand side of the equation to get it out of the way. We can bring it back over, add 5/3 to both sides of the equation. Now this is g of x, right? This is what we were working with. So the problem was not to take g of x into vertex form, which it is right now. The problem was to take f of x into vertex form, which is why I always write it out explicitly. I see a lot of students get to this point and forget to multiply through by whatever your original a value was. So we converted g of x from standard form to vertex form. So now we just got to multiply g of x by negative 3 to get f of x. So I did that right here. And so this is our final answer, f of x converted into vertex form.